Hello again. In this lesson we're going to talk about using variables in Visual Basic, what they are, how to declare them. I'll explain what data types are and how they fit into the picture, and then how to convert values from one data type into another and so on. Then we're going to talk about the difference between statements and expressions and look at different types of each. So let's go ahead and get started right now. We'll start by talking about one of the building blocks of code, which are variables. If you remember back to high school algebra, you might remember a math problem that looks something like this. X equals 3, y equals x plus 7. So what does y equal? Now in this problem there are two variables. There's x and there's y. And we can easily see that because x equals 3, that y should equal 10. At their essence, these variables simply represent some value. They are buckets that contain a value. In computer terms, a variable is a space in the computer's memory where it stores a value. And we as programmers can reference the value in the computer's memory by using a name that we give to that particular value called a variable. Also in algebra, we worked with only numerical values, but variables in programming languages can contain strings or dates or big numbers or small numbers and a lot more. So in order to know how big or small to make the bucket in the computer's memory, we have to declare a variable and tell the computer what type of information we plan to put into that variable. So I've taken the liberty of creating Lesson 04, which is just a simple Windows Forms application. And you can see that I've already placed two text boxes, a button, and a label onto my Forms Designer surface, and I left their names the default, didn't change any properties, but we are going to start writing some code under the button one click event. So I double click the button and I'm just going to paste in some code that I have already typed up a few moments ago. Okay, so let's talk about these three lines of code. Obviously line 5 is a code comment where we can type any free-form information we want to remind us what this section of code does. Line number 6 is dim my string variable as string, and this is a very typical variable declaration. Variable declarations must start with the keyword in Visual Basic, dim, D-I-M, and this will tell the computer's memory that we are about to put something inside of it called my string variable, and it will hold string values, and we'll talk about strings in just a moment. Also, we have another example of a variable declaration in line 7. Dim my initialized string variable as string equal to Bob in quotation marks. Okay, so during the declaration we can also initialize its value. Initialization means that we take two steps in one line of code, both declaring the variable and setting up its space in memory. And then the second step is setting its value immediately. So we define how big the bucket is, and then we immediately fill up the bucket with something. In this case, the string literal of Bob. Also notice that the myString variable has a little green squiggly line underneath of it. This is to let you know that we've declared a variable, however we've never used it within our code. So while this is not a problem, it's just a friendly reminder that you've created a variable that you never really used. So let's move on. I'm going to paste some more code in. And as you can see in these first two lines, in lines 6 and 7 that we created just a moment ago, we created two variables. Each of their types are strings. So you can see that we use the as keyword and then the variable type, which is string. But also we can create different types of variables that are numeric in nature. Strings can contain alphanumeric characters, both numbers and letters. However, if we need variables that can be used for mathematical equations, then we would need to use one of the several numeric data types that are available, such as an integer, which can contain values from negative 2,147,000,000 to a positive 2,147,000,000. We can use the double, which as you can see is a very large number. Also, the thing about the double is that it allows us to include decimal places. Or we can use what's called a Boolean, which is a 0 or a 1, a yes or no. So you would use these whenever you're trying to evaluate whether something is true or false. And there are a lot of other data types that are available, but these four will help you get a long way as you're first starting out. So just one or two little gotchas before we move on. In Visual Basic, you have to use the proper spelling everywhere you reference a variable, obviously. You can't misspell variable names throughout your code. But your use of capital or lowercase letters doesn't matter, and that's different than other programming languages like C#, for example. So if you were to have my integer, where the I in integer is a capital letter, and you have another variable in your application called my integer with a lowercase I, these are essentially the same variable. There's no difference between these. Again, unlike other programming languages where it would treat these two variables as two separate, distinct, different variables. The two lines of code are exactly the same. In fact, in Visual Basic 2005, the code editor will correct the capitalization to remove any confusion that you might have based on the capitalization of what you dimensioned the variable to be originally. Okay, so let's also take a moment to talk about strings. Whenever we type in a string, like we did in the Hello World application, we used quotation marks around the text. And we also used quotation marks just a moment ago when we initialized our string variable equal to Bob. Now, why do we do that? Well, it's really simple. It helps the VB compiler distinguish between what's called a string literal versus a variable name. Now, here's one way to make that distinction. The variable is a bucket, and the string literal is what goes into the bucket. A string literal could be a message that we want to display to the user. It could be values that we want to save into a file or in a database, or it could contain a file location on your hard drive or any text that has meaning within our application. So let's take a look at another little example here. Okay, so I'm going to paste in some more code here, and let's take a look at example 1C. Okay, we have in line 17, dim hello as string. Is hello, in this case, a variable or string literal? It is a variable because we have used the dim keyword and the as keyword, and we have told Visual Basic that we want to create essentially a new variable that has a string data type. In the next line of code, line number 18, we are setting that variable equal to the value hello world. A little misspelling there. Hello world. In line 19, we have a message box.show hello. Now in this case, in line number 19, is the word hello a string literal, or are we referring to our variable? We are obviously referring to our variable hello. But in line 20, what are we doing? We are using a string literal because of the use of the quotation marks. And so we will display the word hello in the message box. So hopefully that helps you see the distinction between a variable name and a string literal. Again, the easiest way to remember it is that the variable is a bucket. It's something that stores value. It is not a value in and of itself. By default, whenever you declare a string in this way, it is initialized to an empty string, like so. A string literal, however, is the value. It is something that you would place into a bucket. And so just keep that distinction in your mind because it'll come in handy as you're getting started. Okay, so we've spent several moments now talking about variables, but why would you use a variable in the first place? What is the purpose of a variable? Well, simply put, its purpose is to save some value off until you're ready to use it, or you're ready to refer to it, you're ready to compare it to something else, you're ready to evaluate it against something else. There might be a dozen different reasons. At this point, let's do another simple example. It might help make more sense. Okay, so here we have example 2. So in line number 23, we have dim first text box as string equals textbox1.text. So what have we done in line 23? We have dimensioned a new variable called first text box. we set its type equal to string, and then we initialize the variable to contain the value that's in our textbox1.text property. Now you recall from whenever we originally built this application that we have two text boxes. This one is text box 1, this one's text box 2. Okay, so what we're going to do is take the value from text box 1 and place it into a variable called first text box. We do essentially the same thing in line 24 where we dimension second text box a string equal to text box 2.text. Now this is where we are starting to talk about the use of variables. And admittedly this is a very simple example, so the true meaning may not come out here. You might still not have this question answered in your mind. However, you can see in line 26 what I'm able to do now with the value I've retrieved from the first text box and the value that I've retrieved from the second text box. I'm able to concatenate those together and put a space in between them and set that value, that expression, equal to label1.text, which is another control that's on our form. So I'm able to take the value out of a text box, which is input by our user. I'm able to work with it, to manipulate it, to change it in some way, and then combine it together with other variables that are stored within my application. And again, very simple example. This may not help you conceptualize it completely, but let's use this as a working definition and continue on. Okay, so now that we've talked about the purpose of a variable, let's move on to a slightly more complex case. To paraphrase something that I said a little bit earlier, whenever you declare a variable, you're creating a space in memory that can hold a value of a certain data type. Some data types require more space in your computer's memory than other data types do. So what happens if you try to put a value into a variable that's already been declared as one data type, but the value that you're trying to put into that variable is the wrong data type? What's going to happen? Well, the answer is not so simple. Now, in some cases, the value will be what's called implicitly converted to the correct data type, which simply means that the Visual Basic compiler will perform the conversion for you, and you really don't have to think about it. So here is an example of an implicit conversion. Okay, we have my value as integer in line number 30, and then in line number 31, dim my other value as double equals 3.14. And then we set my value equals to my other value. So let's do this, messagebox.show, and then we'll do something like my value. Okay. Now, whether you realize it or not, I have basically done two implicit conversions here. Where's the first implicit conversion? In line 32, where I am taking a double, which, as you know, can be a larger value. It can store quite a bit more information than an integer can, which means that we can pack so many numbers into that when we go to convert it to an integer, it simply won't fit into that spot in the computer's memory. And we can also put values after the decimal point. In this case, I've set my other value, initialized it to 3.14. Now, what will happen whenever we try to do this implicit conversion? What will the Visual Basic compiler do? Will it choke? Or will it actually try to do this conversion for us? Okay, so that's the first question. Then the second question is in line number 34, where we do another implicit conversion. Can you see where it is? The messagebox.show method accepts a string value, but my value is an integer value. So how does this work? Well, let's go ahead and see. Before I do that, however, I want to comment out all this other work that I've done. So I'm going to select it by using my mouse cursor, putting it at the end of the last line of code, and then slowly drag it up to the top. And then I'm going to use my handy little button here, comment out the selected lines, which, as you can see, will take all the code that I've written, and it will put a little quote mark in front of it. And if I ever need to uncomment out these lines, for example, I can just use the next button, which is uncomment the selected lines, and it will remove the comments. So for right now, I'm going to comment all these lines, and we're going to get back to our example at hand. So what do you suppose will happen here? Let's run the application and see if it even works, first of all. And we're just going to click our button, and you notice that we get the value of 3. Okay, now was that the result that we were expecting? Again, we're taking the value of my other value, which is 3.14, and we're going to pack it into another variable called my value, which is type integer. So the first thing that we notice is that it stripped off the 0.14. It performed the conversion for us, but because that the values after the decimal point won't fit into an integer because integers don't have a concept of a decimal point, that value was stripped off. Now the next conversion wasn't so damaging to the underlying values. It simply changed our integer, our numeric value, into a string value that could be displayed within a message box. So that is why I've used this little term off to the right-hand side in line number 29, that implicit conversions can be dangerous because, as we saw, we lost data whenever we were trying to cram too much information into a variable that simply couldn't hold it. There will be truncation of data or loss of data. And from experience, sometimes implicit conversions can cause things to happen within your application that are difficult to track down and difficult to understand why you're getting the results that you are. So you should strive to never rely on implicit conversion within Visual Basic. Instead, you should use explicit conversion and take control of the conversion process. Okay, so let me show you another example that highlights this a little bit better. Let's start off with 3 variable declarations beginning in line 36. So we're creating first text box as integer equals 0, second text box as integer equals 0, and result as integer equals 0. So we have 3 integer variables that are declared. The next thing I'm going to do is paste in 2 more lines of code in lines 40 and 41. I'm setting first text box equal to textbox1.text, second text box equals textbox2.text. Now can you see where I'm relying on implicit conversion here? What will the .text property return to me? It will return a string value. I can just put my mouse cursor over that. You can see off to the right hand side, public property text as string. So we're going to count on an implicit conversion here. We're also going to trust that our users will type in a value that can be converted to an integer. Next, in lines 40 and 43, I pasted in 2 more lines of code. Result equals first text box plus second text box. And then finally, label1.text equals result, where again we're relying on implicit conversion to do our work for us. Okay, so let's save this and let's run our application. Actually, let's do this. Let's comment out this example and then run our application. So simply what we want to do is take 2 numbers and add them together. And then when we click our button, it will display the result here at the bottom. So a mini calculator. 9 plus 8 does equal 17. Let's run our application a second time, and here we'll put 9 and we will spell out the word 8 and then click our button. And notice now that we are going to have a problem. We get an invalid cast exception when unhandled. The conversion from the string 8 to type integer is not valid. Let's stop the execution of our application. So you can see that there is a problem here, that we have relied on implicit conversion, and it has posed a problem for us, that it could not perform the conversion because it couldn't fit the values into the value 8, which is a string, into the second text box, which is an integer. Visual Basic does not know how to translate English words into numeric values. Now let's modify this example. We may still get some similar results. However, this is the preferred way to go about it. We're going to set first text box equal to, we'll go ahead and type in textbox1.text, but I'm going to do what's called a conversion. So I'm going to take integer, which is our data type, and this data type has a special method called parse, which will accept a string value and it will convert that string into an integer before placing the value into our first text box. And we'll do the same thing here. Second text box equals integer dot parse textbox2.text, and we're going to talk about integer.parse in just a moment. And then also, instead of relying on this implicit conversion where we're setting the result, which is an integer, equal to the text property, which is a string, we're going to use another little special method called toString. Okay, so what is the difference between lines 40 and 41 and lines 43, 44? Well, the difference is that we are employing explicit conversion, which means that you are writing the code to perform the conversion. The Visual Basic compiler is not going to perform the conversion. You are taking the reins. You are the one in control of the conversion process. So this is where things get a little bit tricky because it might not make a lot of sense at the moment. So take what I'm about to say at face value, and then later on in your learning, you're going to understand the why instead of what I'm about to show you, which is the how. If you want to convert a string value into a numeric value, you simply enclose the string variable or the string literal in one of the following. If you want to convert a string literal into an integer, you use integer.parse. If you want to convert it into a double, you use double.parse. And then if you want to convert it into a Boolean, you'll type in boolean.parse. Now, conversely, if you want to convert a numeric value into a string, you would do the following. You take the, like in this case, my integer value dot toString with parentheses at the end. Now, if you'd like to learn more about how this works, the why, you're going to need to understand the difference between static and instance references to objects, which is a little bit more advanced. We're going to begin to cover objects and references in lesson 6, so just hang in there, and perhaps this is going to make a little more sense as to the why I use the dot parse and the dot toString methods in order to perform a conversion. At this point, I just recommend that you keep in mind that in order to perform a conversion, you're going to need to use these methods in the manner that I've just shown you. So now let's take a look back at our example. You can see that we're still going to have a problem here, that no matter what, if I were to run this application, even by doing the explicit conversion, that I still can't work with this scenario. You're still going to get an exception. Input string was not in a correct format. However, what we're going to do is at some point in the future talk about being more proactive within our applications to check user input before we just blindly accept the values and then go about doing any work with those values, whether it's doing calculations as we're trying to do here or saving the values into a database. And even though the results are going to be the same in this simple example, I assure you that when your examples and when your applications get a little bit more complex, you'll want to take control of the conversion process by doing explicit conversions. First of all, it shows others that you know what's about to happen within your application, that you're taking control and that you are expecting a conversion to happen here. And then secondly, it's going to catch those particular instances at compile time whenever you're compiling your application to be distributed, where a potential conversion could happen that would adversely affect the application. Again, it's difficult to give examples of that at this point, but as a best practice rule of thumb, you should always try to do the conversion yourself and not rely on the Visual Basic compiler to do it implicitly for you. Okay, so let's move on. Let's finish up this lesson with some terminology that we're going to need for the next lesson. Now, we've written a few lines of code so far, but what makes for a well-formed line of code from the Visual Basic compiler's perspective? If we were to write a line of code that looked like this, dim x is integer, and then the next line, x plus 3. Now if we were to try to compile these two lines of code, we would get an error. Why do you think that is? Why do you think we would get an error here? Well, the reason is because x plus 3 is not a statement, but rather it's an expression. In other words, it's only half of what Visual Basic needs in order to execute this line of code. Or, to put it another way, it doesn't really do anything. X plus 3 doesn't do anything. So we got to think in terms of statements. And what is a valid statement? Well, there's several different classifications of valid statements. A valid statement can be a variable declaration. So, for example, dim x as integer. Or an assignment, where you might have my integer equals 3, or my integer equals x plus 3. You can have a call, like a method call, and we've done this several times already. MessageBox.show, that's the method we're going to call, passing in a literal string of hello world. Or a valid statement could be a new object declaration. We're going to talk about this one in lesson 6, so just hang on to that idea. So as a rule of thumb, expressions can be evaluated, statements can be executed. So what are expressions? Well, an expression can be evaluated. What does that really mean? An evaluation is what you do with math problems, right? You evaluate the answer by adding or subtracting or multiplying or dividing or operating on the values in some way in order to determine an answer to the problem that's in front of you. Evaluating an expression is something that we're going to be using quite a bit in the next lesson on branching and recursion or iteration statements. And in those cases, we're going to be doing a different sort of evaluation that I want to really prep you for right now. We're going to be doing the type of evaluation that evaluates to either the statement or the expression is true or the expression is false. So I want to do a couple of quick examples before we close up this lesson, just to get you kind of your mind tuned in that direction. Okay, the first one, 3 is less than 2. Is that true or false? Obviously, that's false. Let's do the opposite. 3 is greater than true. Is that expression true or false? It's true. Okay, so let's go on a little bit of a harder case. Dim x as integer equal to 3. X equals 3. Is that true or false? Well, obviously, that is true. And let's do one last one. Given that dim y as integer initialized to the value of 4, is 4 not equal to, greater or less than, 3? Is that true or false? That's obviously true. 4 is not equal to 3. Okay, so I think you get the idea, and this is going to be important. It might seem so obvious, but we're going to use this in the next lesson quite a bit. So in this lesson, we talked about variables, what they are, how to declare a variable. We talked about data types, and we talked about 4 or 5 of the most popular data types: string, integer, double, and Boolean, I believe. And there's also a number of other ones. And again, these are the 4 that are going to get you the farthest to begin with, and you can tack on some additional ones as we continue through this series of lessons and as you progress past these series of lessons. We also talked about what expressions are and how they relate to statements. We talked about how expressions can be evaluated, and then statements can be executed. Statements usually include some sort of an expression inside of them, okay? And then we talked about some examples of some expressions that we're going to use in the next lesson. And if you enjoyed this video and this series of lessons, please visit www.learnvisualstudio.net to download and watch over 400 videos just like this one, aimed at all skill levels on many different topics related to C#, Visual Basic, ASP.NET, and more. Thank you.